Right, we are just starting with displaying data, and we've got a whole bunch of information to read through, so let's go through it. The subject of statistics begins as descriptive statistics, which develops various systematic approaches using tables, graphs, and summary statistics. Summary statistics is your mean, medians, modes, ranges, that kind of stuff, so that we can see the big picture. Very quickly, however, statistics is combined with probability theory, inviting the language of prediction to be used and leading perhaps to a discussion of causation, which is also fundamental to science. There are two types of probability distributions. We dealt with probability theory and discrete probability distributions in year 11. We will deal with continuous probability distributions this year in year 12. So we have a review of a whole bunch of terms here. It says review of year 11. First thing we have here is a random experiment. So throwing 3 coins into a bucket is a random experiment because there is more than one possible outcome. Okay, so that's how we define a random experiment, if there is more than one outcome. Deterministic experiments, throwing 3 coins into a bucket and counting the number of coins, is deterministic because it doesn't really matter what the results are, head or tails, there's still 3 coins in the bucket. So if we're saying how many coins are in the bucket, that's already determined. There's always going to be 3. There is only one outcome. A random variable, which we use the capital letter X to represent a random variable, is the result of running a random experiment. It can be numerical or categorical. Numeric means numbers, okay, so you can have number answers. Categorical means word answers, so it could be what is your favourite colour, that kind of thing, a word response. If it is discrete, boys, if it is discrete is a type of numerical data where the values can be listed. Maybe a better description there is discrete is usually considered to be whole numbers versus what we call continuous data, which would be something when you're measuring someone's height. You could measure to millimeters, to micrometers if you had an accurate enough scale, that kind of thing. But something like if you're talking about how many goals you kicked in a soccer game, you'd only be counting whole number of goals. You can't have a 0.5 of a goal. Does that make sense? So discrete is thought of as whole numbers. Scores. When an experiment is run many times, the outcomes are called scores. The sample is when an experiment is run many times. The finite list of all the scores is called the sample. So when you roll a dice, the numbers 1, 2, 3, 4, 5, and 6 are the sample that you could get. This is a frequency table, and it also has a cumulative frequency table. So this is the dice, 1, 2, 3, 4, 5, 6. There's a tally, so you're rolling the dice, how many times did that number roll? And then you just convert that tally into a frequency, just counting the number of lines. And then we have something called a cumulative frequency, which means starting with the first frequency of 2, you want to add on the 4 to get 6, then add on the 3 to get 9. You're adding on the next frequency number each time as you go along. Cumulative, they're adding up as you go down the line. Okay, median is the middle number. Make sure that your numbers are placed in ascending order, and then you need to locate the middle. Mode is the most popular score. There can be more than one mode, and you don't average them like you would a median. If there's 2 things in the middle, we average them. But a mode, if there is 2 things that both happen 3 times, we call it bimodal, and you would list both of those things as the mode. The range is the highest score minus the lowest score. All right, next section. There's a little bit of new stuff in here. There are many different ways to display data. We can use histograms and polygons. They're probably the most common ones that we're used to. Hopefully you remember those, probably from year 10. I don't think we did these last year. There are pie charts and other types of graphs as well that you would have learnt way back. 2 ways of displaying data that we're going to be looking at include a Pareto chart and 2-way tables, which we call a contingency table. So the Pareto chart is a new name, but it's not as scary as it sounds. So let's read what it is. A Pareto chart is a frequency histogram. So that's the one you do the little columns, you have the little things coming up, the histogram. and a cumulative frequency polygon on the same graph. That's a normal histogram, not a cumulative one. The histogram is a normal, straightforward one, but the polygon has to be cumulative, and they're drawn on the same graph. They are normally used with categorical data for the purpose of displaying issues in descending order of importance. I did skip over one part. It does say the categories have to be arranged in decreasing order of frequency. So you need to put whichever happening the most needs to be first and decreasing as you go so that it's kind of tapering off as it goes up. A two-way table or a contingency table can be used to investigate whether two variables are related and make estimates of conditional probability. We're going to see all of this. All right, here we go. Question time. Question number 1. Consider the test results of a spelling test that was given to 40 students and had a maximum possible mark of 10. So you can see across the top here, the mark, anything from 0 through to 10 out of 10. And then we have a tally, which tells us how many people got each score. And then you count that up to get the frequency, and even the cumulative frequency is done for us. Everything is filled in for us. Lucky us. Okay? So what do we have to do? Explain how to use the cumulative frequency table above of the 40 spelling test marks to calculate the median and the mode and the range. Okay? So, to find the median, we don't just have a big long list of things that we can cross off beginning and end. We have this big massive table with 40 results in it. So, what you want to do is find the position of the median, and the position can be found with this little rule here. The position is n plus 1 over 2. N stands for the number of results that you have in your data set. Okay, so we have 40. So if I do 40 plus 1 over 2, that gives me 20.5. That is not the median. Sometimes people will do that and go, oh, the median must be 20.5, and that actually sounds reasonable considering that there's 40 scores, right? But it's only the position of it. What you need to do is now come up to your cumulative frequency. You probably could do it up here if you really wanted to count all the tallies or something. But come up to your cumulative frequency and we want to find 20.5. That 0.5 means we're actually between two scores. We're between the 20th and the 21st score. So cumulative, we have 15 scores up to here. And that means 16, 17, 18, 19, 20, 21, all the way up to 23. Those scores are all in that next one there. So the 20 and the 21 would all be in here, which is a median mark of 6. Okay, so I'm going to write over here that the median is equal to 6. Does that make sense how I did that? Hopefully. It's been a while since we've done this kind of data. Let's go on to the next one, mode. Mode stands for the most occurring, which means the one with the highest frequency. So you could look at the frequency row here and find the biggest number, which I think is that 8, which means guess what? That's a score of 6 again. And the last thing we're asked to find is the range. Range is found by doing the highest score minus the lowest score. What is my highest and lowest score? 10 and 1, good. Didn't say 0, because no one got 0. There was no one here. Okay, so my scores up here, 10 happened, and then 1 was the lowest. So 10 minus 1, which means the range was 9. Okay, second question. Secure roofs often arrange as a repair, but for various reasons that repair does not take place on the scheduled day, causing loss of income for the company, while salary and other expenses still have to be paid. The manager organised the last 200 such failures into 6 categories, as in the table below. So reason that jobs weren't getting done. There was a blackout 4 times, so they obviously needed their power tools and they couldn't work. The employee didn't arrive. Oh, that's not a good one. 6 people. Illnesses of the employee, 16 times. Owner not at home, 64 times. Rain, 88 times. The truck broke down and they couldn't get there, 22 times. And so that's 200 things that stopped a job from happening. Okay. So the next thing we're asked to do, here it is that we're going to draw a Pareto chart to represent that data. Now, the first thing we're going to do is draw a histogram, and the histogram will be like a vertical column graph, okay, without any gaps. So that means on the bottom we need our categories. But there was one little condition that I told you. I'm not going to put them in the order in the table. I have to put them in. Does anyone remember? Highest frequency through to lowest frequency. So I have to look up here and go, which thing happened the most? Oh, rain was the biggest factor. So rain has to be the first thing down here. Okay. Next after rain, so that's the 88. So I've done that one. The next biggest one was that the owner was not at home. Okay, so I've done that one and that one. Next biggest one is 22, the truck breakdown. Okay, that's done. Then illness of the employee. I'm just going to write illness. Then employee not arriving and a blackout. Okay, so this is a graph. I do need to label my axes. So this is going to be the reason for no repair taking place. I'm just going to say no repair. Reason for no repair for these poor people's roof. Hope it wasn't rain because they're getting, anyway. Now, on the vertical, we need to have two things to consider here. We're obviously going to have to do the frequencies for the histogram, but what does the polygon do? Anyone remember? Polygon must be cumulative, which means if there's 200 things, 200 scores in here, when I add all my frequencies up, my highest thing needs to be to 200. Doesn't matter that all my little individual ones are much lower. I need to get to 200. So to fit that in, we have to go up in 20s. We're going to have 0, 20, 40, 60, 80, 100. It's nice of this to be just perfectly the right size, isn't it? Okay, label the axes. This is going to be frequency for the histogram, cumulative frequency for the polygon. Okay, so starting with the histogram, let's go through and draw our little columns. So rain happens 88 times. Now, this is not going to be perfect. And if you have a ruler, they're graphs, so they do need to be somewhat neat. Don't make them too wobbly. Owner not at home was 64 times. So 64 would be about there. So no gaps between the columns, they're all next to each other. Truck breaks down was 22. Illness was 16. Employee not arriving was 6. And a blackout is even smaller, 4. Oh, they're getting a bit small there at the end. That one needs to be slightly lower. There we go, a bit lower. So you can see we got our order correct because they are getting smaller and smaller as we go down. Now we need to draw our cumulative frequency polygon over the top. So, do you want to go through, I don't think we can actually, our table's not in the right order, that's going to make things confusing. I think we'll have to add it up as we go. For rain, when it's cumulative frequency, we have to start down here at 0, and there were 88, so here we are up at the top corner. So it's going to go from corner to corner. When you're doing cumulative frequency, they always go corner to corner, but now it's going to leave because we have to add it on. Then I want to add on the owners not at home. We have 88 so far, and we're going to add on the 64, which means we're at 152. So 152 will be about there. Okay, then we're adding on the truck breakdowns, which means we're adding on 22, which takes us to 174. So 174 is about there. Then we're adding on illnesses, so plus 16, which is 190. Then we're adding on, what was next? Employee not arriving, plus 6, 196. And then finally add on the final 4, which will take us to the complete 200. Okay, so my ruler won't come up. I'm going to have to freehand. So try to rule between, these should be straight, very straight, don't bend it, straight intervals. That are increasing, increasing, increasing all the way up, and that is a Pareto chart. Okay, question B. Describe, now, okay, this topic does overlap with the standard course. Pareto charts is something that they have to do. So this section is actually a section that is quite common to be the commonly asked questions between the advanced and the standard exams. So you may then find there's more of these kind of questions that require you to describe things. Okay, so describe what actions the manager may decide to take using your chart. So what you want to do is you want to look at these reasons why this poor manager is having to pay people that aren't actually doing any work for the day. And we want to try and minimise that. So what can they do? What could they do about the rain? Get what? Rain safe where? Probably still can't work on the roof. What about if they only booked in an appointment a few days, or confirmed an appointment a few days in advance, so they could have a reasonable understanding of the weather forecast? You know what I mean? So you go, we think we're going to arrive in, that's not a good customer service? A week beforehand. Oh well, I'm going to write. It's not perfect because no, we can't predict the rain. So I'm going to do a bunch of them. Book external roof repairs. Maybe they could do internal ones anyway. All right, so we're trying to look at the weather forecast so we have a bit more of an idea of if the rain is going to impact us. So we're only confirming, locking in our dates when we have that 3 days in advance. What about the owner not at home? What should the manager do for that? Give them a call, confirm that you're coming. Are you still going to be there? Just remember we're coming the next day. So let's say confirm appointment the day before. All right, what can we do about breakdown? That was our next highest one. Truck breakdown. Get a better truck, have a spare truck, maintain your truck. Any of those kind of things. Which one am I put? Better maintain the truck, have a backup truck, have a backup. Okay. Illness. Yeah, probably can't do much about it. Well, that's probably enough. We only need a few reasons. Is that enough? Or okay, you'd have backup. You'd have calling people, right? If someone's sick, you should have extra staff on call for sickness. Okay, that's enough. Part C, determine the mode. Most occurring. Rain was the highest one. Over the page, question 3. A survey asked 200 adults what colour phone cover they preferred. Responses were recorded, black, brown as being dark or coloured. So if you like black, brown, you were put into the dark category. Or if you wanted another brighter colour maybe, then it was just put down as colour. And the gender of the person was also recorded. The resulting joint frequencies are tabulated in a two-way table. So we're going to the table form now. Okay. So, first of all, we've got some blanks there that we need to fill in. They're the sum. So you either sum down the columns or across the rows. Okay, so going down, 38 plus 56 makes 94. 12 plus 94 makes 106. Going across the row, 38 plus 12 makes 50. And 56 plus 94 is 150. Now, it shouldn't matter which way you go from here. 50 plus 150 makes 200, and 94 plus 106 also makes 200. If they don't both make the same thing, something's wrong somewhere. Question A, complete the two-way table. Done. Explain how to analyse the two-way table to answer the question, do men prefer dark colours more than women? How could we're not going to write the explanation, but what kind of thing would we be calculating from that table that we could make that kind of call? What did you say? Percentage, or which is like based on the probability, right? That what's the chance or the probability of people in there that men or women that prefer the dark colours. So let's look at the men first. So of the people who like dark colour, the men that like dark colours, 38 out of a total of, so here's the men, 38 men like the dark colour. What would that be out of? 50. There were 50 men. So there is 38 out of 50 men that liked dark colours. Now, if you want that as a percentage, you would times that fraction by 100, which gives you 76%. Okay, now let's have a look at the women. Okay, so how many women chose the dark colour? 56, which is a lot more people, but what is that as a probability of how many there were? How many women were there in total? 150. So we have 56 out of 150 women. So because there were so many more women that were surveyed, that's actually a much smaller fraction. Times that by 100, and that's only 37.3 approximately %. Okay, so do we agree with the statement, do men prefer dark colours more than women? According to that table, yeah, significantly. 76% is a much, much higher choice of the darker colours than 37%. Okay, so we're just going to say, yes, that will do. Based on those results, yes, that is a fair conclusion. B, if a person was chosen at random from the survey, determine the probability that they prefer dark colours. Do we care if they're male or female this time? Nope, it's just the people that like dark colours. So, looking back here, I'm going to shrink it down so hopefully you can see both at the same time. How many people like dark colour phone covers? 94 out of a total of how many? Yeah. Now, the question does not say whether to do fractions or percentages. So in this case, it would be up to you as to how you want to leave that. You could either simplify the fraction down, which would give you 47 over 100. Well, that just becomes nice, doesn't it? That's just 47% if you do want the percentage. Either answer would be acceptable if they haven't specified what they want there. Question 2, we want the probability that they prefer dark colours given that they are a man. Probably remember that from year 10, that word given, right? So if I underline it, given. So given that they're a man means we're only looking at the men for our total. There are 50 men in total, and of the men, there were 38 out of 50, which is what we did before, that prefer the dark colours. So that's either 19 out of 25 as a fraction, or our 76%. Doing that quickly because that was the exact same one as this one up here. Okay, I'm going to have to make this bigger. Can't write that small. Question 3. Prefer dark covers given that they are a woman. So there's the word given again. So only looking at the women, which means we have a total of 150 people, women, 150 women. How many of them like dark covers? That's 56. It's a bit of a repeat. We're doing the same thing again. 28 out of 75, which was our 37.3. I'm just going to round to the nearest whole percentage. 37%. That was the same as up in part A, making us repeat ourselves. Question 4. It just says, is a man. What is the probability that they are a man? A quarter. Yes, because there are 50 men out of the 200, which is a quarter or 25%. I'm putting both just so you can do both. What is the probability that they are a man given that they prefer dark covers? So there's 38 men that prefer dark colours. How many people like... So when it says given that they like dark covers, the people that like dark covers is the total at the bottom, which is what? 94. Is that what you said? Yeah, good. 94. So given that they like dark... Sometimes it's better to start with that last part. Given that they like dark covers, 94 people like dark covers. And what is probably that they were a man? 38 of those people that liked dark covers were men. Simplifies to 19 out of 47, which is approximately 40%. And last one, are a man given that they preferred coloured covers? Okay, so let's do the given part first. How many people liked coloured covers? 106. And how many of those 106 were men? 12. So that's 6 out of 53, which is 11%. Okay, so data and probability all mixed together. What fun, fun, fun.